In this next section, we're going to look at when my radical has a variable in the radicand. So at the top of our notes here, it says it's only possible to take the square root of variables with even exponents. Or I could also say variables with even exponents are perfect squares is probably a better way to say it. I can still work with it if it's odd, but only evens are going to be perfect squares, okay? So let's talk about number one, super, super basic, the square root of x squared. Now think back to our exponent rules. X squared means we had x times x, correct? X to the first times x to the first, and we add those exponents. So the square root of x squared is x. For that reason, x times x was x squared. So number one, the square root of x squared is x, 1x. Let's take it to number two, the square root of m to the sixth. So what times what would have made an m to the sixth? And it has to be the same thing, correct? So m to the sixth could have been m to the third times m to the third, because recall with exponents we add. 3 plus 3 made 6. And so I'll show that here. We had m to the third times m to the third made m to the sixth. So therefore the square root of m to the sixth is m to the third. You'll see some people talk about taking half of the exponent. So half of 6 is 3. But there is a mathematical reason behind that. Let's look at number 3, the square root of 9k squared. How many things are in there? You have 9 and the k squared. There's 2 pieces in there. Let's just write them separately for visuals here. Okay, so what's the square root of 9? 3. What will be the square root of k squared? Okay. Let's write that just a little bit bigger there. There's my final answer. And for the square root of k squared, I'm just using the same idea from number 1. So final answer number 3 is 3k. Number 4, we have 64 and p to the 4th. I'm just going to go ahead and separate those. Those are 2 different pieces. I'm going to take the radical of. The square root of 64 is 8. The square root of p to the 4th would be p squared. Final answer, 8p squared. Everything came out of the radical. Number 5, we have square root of 100, x squared, y squared. There are 3 pieces in this radical. I'm going to write them all separately here. The square root of 100 is 10 out of the radical. Square root of x squared is x out of the radical. And the square root of y squared is y out of the radical. Final answer for number 5, 10xy. Number 6, oh my, how many things do we have? We have the square root of 49, a squared, b to the 6th, c to the 4th. 4 things. For visuals, for our notes, going to write them all separately because we are going to take the square root of all of that. Square root of 49 is 7. Square root of a squared is 1a, a to the 1st. Square root of b to the 6th is b cubed. And the square root of c to the 4th is c squared. Again, notice how those exponents just got cut in half, and that goes back to our exponent rules where we have to add them together. All right, let's navigate. What if we have odd numbers as our exponents on our variables? So what we're going to do is we are going to separate it into as big of an even number as we can with 1 left over, which is why it's odd. And the odd is going to have to end up staying in the radical. Let me illustrate. Number 7, we have the square root of y to the 5th. I can take a square root if the exponent is even, and the closest I can get there is a 4, right? 4 is, okay. So the square root of y to the 4th and a square root of y to the 1st. I'm going to separate them like that because I can do y to the 4th. And then I'll just leave one of those y's in the radical. Square root of y to the 4th would be y squared out of the radical. And one single y is getting left behind inside. Done. Number 8, we have 2 things in that radical. We have the a squared and we have a b cubed. A squared I'm not worried about at all. It's even. So I'm just going to rewrite it in my next line. But b cubed, b to the third, that's odd. So let's break it up into a b squared and the 1 left over. Let's go to work. The square root of a squared is a. Square root of b squared is b, and we left one of those b's inside the radical. Number 9, there are 3 things in here. We've got the square root of x squared, y cubed, z to the 4th. Went ahead and wrote those all separately as I read it aloud. Evens, I'm not worried about. X squared, I'm not worried about. But y cubed, let's make it y squared and 1 left over. And z to the 4th is even. I'm not worried about that one either. So let's evaluate. The square root of x squared comes out as x. The square root of y squared comes out as a y. I'm going to just breeze over that single y because I'm going to put my radical always at the end. Let's jump to the z. Square root of z to the 4th is z squared. And again, we always write our radical last. If I had written x, y, radical y, z squared, there would be a lot of confusion among other mathematicians, other students, teachers. What exactly is inside that radical? You'll never see it written in a formal math textbook this way because people will always wonder, hey, was that radical over the z or not? So we always write the radical last so nobody questions what is inside there. So whatever is your radical in your radical, it's last. It is our tail of our answer. Number 10, we have the square root of 45 into the 4th. I'm going to go ahead and separate each of those pieces there. Square root of 45 is not a perfect square. However, let's use everything that we've learned so far. It does have a perfect square factor of 9 times 5. And the square root of n to the 4th is even. I'm just going to write it in my next line, pulling it down before we start evaluating. The square root of 9 is a 3. Skipping over 5 because I know I can't bring it out. Let's talk about who all we can bring out of the radical. Let's jump to the end of the 4th. Into the 4th, the square root of n to the 4th is n squared, and we have left over the square root of 5. Number 11, the square root of 144 r cubed. Going to separate our numerical and variable piece here. The square root of 144 is perfect square. I love it. It is 12. R to the 3rd is odd. So let's separate it into an r squared and we'll have 1 left over. The square root of r squared will come out as a single r and we're leaving 1 r inside. 12r radical r, or again, you can read it as 12r square root of r. Number 12, square root of 81, c to the 7th, d to the 4th. Not worried about 81 at all because it is a perfect square. I'm going to go ahead and leave a line though, and let's separate this c to the 7th because it's odd. We'll have c to the 6th and 1 left over in our radical, and then d to the 4th is even. So not worried about breaking that apart. Let's evaluate. Square root of 81 is 9. Square root of c to the 6th is c cubed. Breezing over that c to the 1st, that's never going to come out. Let's look at d to the 4th. Square root of d to the 4th is d squared. And again, we have the radical c left over. Final answer, 9c cubed, d squared, square root of c. 13, just like in our last section, there's numbers before our radical. No big deal. Let them hang out. Let them chill. We'll deal with them later. So let's see about our radical. We have this square root of 12 x squared y to the 7th. All right, pulling everything together that we've done. All right, letting 4x cubed chill. Let's talk about this 12. Perfect square factors. 4 times 3. I love it. 4 times 3. Square root of x squared, I'm going to just copy that because it's even. I'm going to be able to evaluate it. It's going to come out of the radical. Square root of y to the 7th, we'll have y to the 6th, and we'll leave 1 left over in our radical. Let's start pulling who we can out. Still letting 4x cubed chill in front. We'll deal with him later. Square root of 4. is a 2. Notice I'm putting a multiplication sign there. Everything that's outside is going to multiply together. I'm going to skip over the square root of 3 because he's going to have to stay. Square root of x squared is an x. Square root of y to the 6 is y cubed. And let's see who's left over. And I really like using this notation on my work, scratching out who I've pulled out, being able to see who is literally still left in a radical. We had the 3 and the y. So I'm not going to forget anybody. All right, all that's left now is clean up that front part. Multiply, combine variables with exponents. So we had 4 times 2 makes 8. We had x to the 3rd and another x. Add up your exponents, right? This is going to be x to the 4th, y cubed, radical 3y is our big final answer. Notice we've really built on everything we've talked about so far with radicals. Let's try again with number 14. There's a 5 outside. We have a square root of 24, x cubed, y to the 7th. Separating each piece so I can get to work. Letting 5 chill. Let's talk about 24. Perfect square factors of 24. 4 times 6. Can I do any better? So 4 and 6. X cubed. Let's break that up into an x squared and an x. 1 x left over. Y to the 7th. Y to the 6th. And 1 y left over. All right, let's see what we can do here. The 5 is outside, in front, chilling. It's going to get multiplied with whoever we pull out. Square root of 4 is 2. 6 is going to have to stay. Square root of x squared is an x. Single x is going to have to stay. Square root of x, y to the 6 is y cubed. And this other y is going to have to stay. Who did I not cross out that's going to be in our radical? 6x, y. Almost done. I just need to clean up that front part. We just have the 5 times 2 to make 10xy cubed, radical 6xy. Final answer. And last and final problem for our lesson here, modeling just the same things we've been doing. We have 8x squared in front. We're going to simplify the square root of 50, x to the 7th, y to the 6th. Going to let the 8x squared chill there. Let's talk square root of 50. 25 and 2. Not a big deal there. Square root of x to the 7th, that's an odd exponent. So let's break it up into x to the 6th and a square root of x to the 1st. The square root of y to the 6th is even. So I don't need to separate that one. All right, 8x squared out in front. Who's coming out? The square root of 25 is 5. Square root of x to the 6th is x cubed. Square root of y to the 6th is y cubed. Who's left inside? Who did I not scratch out? 2x is in the radical. And let's clean up our final answer. We had 8 times 5 makes 40. We had x squared and x cubed. Add our exponents, right? X squared, making notes up here, times x cubed. That means x times x times x times x times x. That's x to the 5th. We add our exponents there. Okay. X to the 5th, y cubed, and then the square root of 2x. Final answer, 40. X to the 5th, y cubed, radical 2x. Final answer. Okay, so again, some of my big takeaways with our variables, even exponents on our variables are considered perfect squares. And we talked about that with the exponent rules and how and why that works. If it's odd, you're just going to break it up into 2 radicals like we did with our numerical square roots, breaking up into 2 products. We're going to rewrite the exponent as a highest even we possibly can, leaving 1 left over. And then we just applied all of our radical simplification rules that we've learned so far. Whether it had something already outside, if it had multiple parts, just practice through these guys. Again, this is a concept that is going to help you next year, and especially in your future math courses that doesn't always get taught. So you're going to be at an advantage having had this lesson this week. So I hope you have a great day. Feel free to ask me any questions, and I'll see you later.